Hello viewers, welcome to another very interesting episode of the semiconductor webinar. Today we will be talking about the hot and very hot SKY130 PDK. Most of you are very much curious about SKY130 PDK, and you will be excited to know that the eSIM has the integration with the SKY130 PDK. In today's episode, Sumanto is going to share with us how the one Sky 130 PDK can be made use of through eSIM. And at the end, he will also point you out the entire IP library that you can use, which is also developed with the help of the Sky 130 PDK. So, uh, we do not need any more introduction to Sumanto because Sumanto already has appeared in TSP and TSW multiple times. So we'll go straight to the subject today, and over to you, Sumanto.
Yeah, thank you once again, Vidul, for introducing and giving me the opportunity to talk about eSIM and SKY130 PDK. So in this, as Vidul said, I will be covering how eSIM is interfaced with SKY130 and how to simulate a circuit from eSIM and using the SKY130 PDK. So yeah, so as you can see my cursor, this SKY130 is also a part of eSIM right now. So I have already created a project using SKY130 and it's a CMOS inverter project. So let me open up the schematic. Yeah, okay, so this is the schematic screen which you can see. So to enter the SKY130 mode, so we use this SKY130 mode, SC mode, which is available from the add a symbol this option in KiCad. And it's loading, so it will take some time. Till then I will explain like SKY130 FDPR PFET I have used here in this inverter, and then SKY130 NFET FDPR FD primitive library NFET 01 volt V5 V8, and rest of the circuit is the same. Yeah, so it has appeared. So in order to access this SKY130 mode, so you need to type SKY130 mode in the component choose symbol search bar, and this will appear. And all the SKY130 components are also available here, so one can take it and just place it here over here. Okay, so also we have different SKY130 sub-circuit libraries. These are predefined IP libraries which one can choose. Yeah, so one can choose and place it over the schematic. So I have already placed one, so I'm not placing it again. Now, yeah, so rest of the things are the default ones: DC source and the pulse waveform. And so only difference between the other components and SKY130 is SKY130, while other MOS components have the designator as M or Q, the transistors. We have the SKY130 in eSIM, which is the designator as SC. So the components will be labeled as SC1. After annotation, it will be labeled as SC1, SC2, and so on. Okay, so these are the salient features of the SKY130 libraries. And yeah, you can use the resistors, capacitors, and inductors available over here. And everything in the primitive libraries can be used over here. So yeah, after building this circuit, you can just one can just export the netlist. The rest of the steps are the same. Click on the export button, and we will be exporting, saving the netlist over here. Okay, so we have exported and saved. Now going back to the eSIM main window, we will do convert KiCad to Ngspice, and so we have entered the start time as 0, step time 0.1, stop time 10 milliseconds. Now the pulse source details. So initial value 0, 1.8. So since we are using the regular voltage, like not the low voltage or the high voltage, so 1.8 is the standard voltage for the SKY130 PDK. We also have 3.3 high voltage components, and so that also can be used here. So I mean, in fact, this 01V8 stands for 1.8 volt. So yeah, so delay time and rest time, fall time, and pulse width and period I have mentioned 50% duty cycle, and yeah, DC source 1.8 volts I give. So again, the VDD, since we are using 01V8 libraries components, so 1.8 volt. Now Ngspice model, nothing, and device modeling tab, very important. So we need to enter various parameters needed by these components of SKY130, and so add parameters of the SKY130 library. So we need to enter the path. So one can add it by clicking on add default. Then the default path which comes with eSim will be added over here. If someone wants to add some other part of the SKY130 library, so one can click on the add button and go to the respective directory and choose the path of the SKY130 file. So this is the sky130.lib.spice is the file which needs to be loaded, and one can even enter the corner by which the simulation in which he or she wants the simulation to be done, like PT corner, SF corner, FF corner, whatever kind of simulation they want to do. Now through this file explorer, I will show what is there inside this sky130.lib.spice file. So the default location which comes with eSim installation is so yeah, by the way, so in earlier tutorials we have used Windows, but currently we are on Ubuntu system. So as you can see, this is completely Ubuntu Linux. Here I am using Ubuntu 20.04, but one can use now eSim is supported on 24 up till 24.04, and yeah, so please feel free to try eSim on Ubuntu. And yeah, so here we have the sky130.lib.spice file. So it has been opened in a text editor, and yeah, so we have all the components, all the other spice component files included. So the first one comes with TT corner, and then rf.spice, sf.spice. So different corners and different cells and different files. So LVT, low voltage, the nominal voltage, and yes, so different files are there over here. So all these files are included in this top level lib.spice file. Now going back to the file explorer, so these are the things, and there are different other files available over here which the user can import while running it through eSim or through Ngspice or some other way. Okay, so now going back to the tech directory, so we have the TLF file, and in the cells we have all the components. So we are using, for example, NFET01P8, and these are the various files present over here. Okay, so this represent different parameters and different things for different corners, then leakages, mismatch, and different other things. Okay, and then in the test directory we have a sample spice file. So I will open up the sample spice file. So yes, so here is the file, and one can go through this file so and check and try it out. Okay. There are also plots given by the PDK developers. So this is how the plots should look like. And this is the behavior of the Sky130. This
Hi,
particular.
Sumant. Sorry for the interruption. Sometimes your microphone might be away from your mouth, so the
Okay.
voice is going low and go high. So can you stay close to the microphone? I think that will help.
Hello. Yeah.
Yeah, it is clear
So
now.
yeah. So yeah. So this is the way. And yeah, and now yeah, going back to the eSIM main window. So basically this we have two different the other options are available over here. So add parameters for the NFET model. So we need to add the different parameters. For example, in transistors we have the length and the width, and different other finger numbers and other things can be added. And so yeah, so here I have added W equal to 1 micro and L equal to 1 micro. And similarly for PFET, I have added the parameters as W equal to 2 micro and 2 micron and L equal to 1 micron. So since we know that the PFET value width should be more than the double the NFET width, so I have added accordingly. And yes, so sub-circuits. So we don't have anything in sub-circuits, but we can even have sub-circuit IPs of the SKY130. But in this circuit, we are using the components only. So yeah, and microcontroller tab is absent. Clicking on the convert button, so it has been converted successfully. Okay. Now we will simulate and check this circuit. So do you want a Ngspice plots? It is asking. So for now, we will just see the Python plotting. Okay, so it is running. So we can ignore these warnings appearing over here. And finally, this circuit, this simulation has been completed successfully, but actually we cannot plot everything. So I will just edit this plot to print only V in and V out output. Now let us simulate. Yeah, so the plot has appeared. So V input, so this is the V input we are giving, passing, and V output is the negated one. As you can see, it's inverting properly. Yeah, one can analyze it more detail, definitely. Yes, so this simulation of this inverted circuit is successful. Now going back to the netlist, so let us look into the netlist. And so when we have converted, and so this the following library files get added. So one can definitely look into the library files models present over here and add some more library files according to the requirement over here manually. And so XSC is the sub-circuit name which the SKY130 has been made for the SKY130 models. So NFET model, and the width and the length has been specified here. Okay, whatever we passed as the input, and the pulse source, DC, and the DC source, transient, and so on, printing the values and current and different other things. Okay. Yes, so this was all about the waveform, this simulation of the inverter circuit. Similarly, one can even simulate IP. For example, I have uh, simulated the following thing present over here. One can go and check afterwards. Yeah, okay. So now I will go back to eSIM window over here in the resources. And yeah, so in the resources we have different so one can check this SKY130 analog IPs libraries. So just clicking on it, yes, so here lot many IP libraries are available which one can simply download. And yeah, these are the sub-circuit libraries. So also the .lib files are present, so load the .lib file in the KiCad and build schematic using this, and just use this IP as different modules. So these are open source, completely open source, released under GPL license, and yeah, so one can use it. And here are the steps mentioned: how to use it, how to run it, different other things. And for to know more about the IPs, one can visit the following website and the resources page. Okay. Yes, so these are all the things about SKY130 PDK and the IPs available. Let me show you into one of the IPs maybe. So as you can see, the lib file is present, which can be loaded in the KiCad and the subcircuit file. So you can see the subcircuits of SKY130 are present. So simulation steps are same as the one which I have shown for this for the inverter. Okay, so yes, so that's all I wanted to cover for this webinar. So Vidul, over to you.
Yeah. So thank you, Sumanto, for this very short and sweet uh, usage of Sky130 PDK inside eSIM. Now, in our channel, we got multiple question about the Sky130 PDK because many of the students they want to try it hands-on, and now the students. I would like to change the layout before I go. So now the students you can try out the eSIM feature that directly can access the Sky 130 PDK, and I think the Sky 130 PDK is coming pre-installed in both of the Windows and Linux version, right?
Correct. Both. It's available on both Windows and Linux.
Yes. So the students who are using the Windows, they don't need to bother about it because initially the Sky 130 PDK, what I faced that it is available, the paths, etc., all things are defined for Linux system.
Mhm.
And now I think Sumanto and his team and Professor Kanan Modgolia's team, they have implemented it in the Windows also. So that is a very very huge benefit because not all students are having the Linux in their system. However, slowly they are adapting the Linux. But however, for now on, what they can do is that they can use the Windows version of the eSIM, and that also has the Sky 130 PDK.
Correct.
And the beauty which you got in today's demonstration is that you got the Sky 130 PDK plus the entire IP library. Now, students, what I would like to say to you, IP library is different designs that are designed by the, I think, the eSIM team and the subsequent marathons and all the activities under the eSIM hood in IIT Bombay in Kanan Moudgalia's lab. So, yeah, once you have all these pre-ready circuits, you can try them out. You can plug them in the schematic, and you can try out different things. And the beauty is that the Sky 130 is feasible for tape out. That means you can tape out an analog chip using Sky 130. That means you are going close towards building a physical IC using the eSIM library. So thank you, Sumanto, for bringing this feature to our viewers, the entire student community as well as the engineering community. I know that many of the engineers are inquisitive about having hands-on on the Sky 130 PDK in different ways because it do not only contains the analog but it also contains the different other parts of the IPs like foundation IP, etc. So what the beauty is that at least in under one hood, that is under one roof, you have all the features used in eSIM. The eSIM cockpit is able to draw the schematic, do the simulation, as well as have the analog IP library, which is under eSIM, and the Sky 130 PDK compatible features. That means you don't have to manually plug in the Sky 130. It is already there. It is already preloaded, and you can use them as is, right? So that is the beauty of the thing. And me and Sumanto are having some discussion. We'll have some more sessions on this eSIM, and this will be very interesting for you guys. I don't see any questions or comments today, so I would like to close the session here to keep it brief and to the point. Thank you, viewers who have joined live today, and thank you to all of the viewers who are watching this later on. So, thank you again, and thank you, Sumanto, for presenting the eSIM feature. And I think we should be proud of what we have already in India, what is uh, in the open source domain already, what we have, and we should celebrate this as our indigenous solution towards the analog design. So viewers, thank you very much. We will be logging off route right now, and so bye. Thank you, folks.
Thank you, Mridul. Thank you, all the participants over here.
So I would
Keep
like to end the stream now. Okay, thank you for joining and attending.